Hello, I'm Whisper, and this is Dyson Sphere program. We are in Sandbox mode because I want to make a blueprint, and I thought I may as well show. Essentially, I want a bunch of frame material for the Moor planet. There's a nice spot between there. It's going to be close to a black box, though not quite. You don't normally just do black box for, say, frame material. So let's look at frame material. Takes a bit of stuff. It's used in a lot of stuff in a mall. Quite a bit in Dyson Sphere, and quite a bit in destroyers too. Yes, alright. Okay, maybe this isn't as crazy as I was halfway thinking. Anyway, let's get back to frame material. Now, what do we need for it? Okay. The idea with the black box is you pretty much grab everything, raw materials, and you process it on site. No extra leftovers, nothing like that. And you just get out your output. And this is going to be our output. And raw materials are on site. Well, this one I am going to treat as raw material. That's because we are grabbing spiniform from out in La La Land. Where is that official? There. Well, normally, heuristically, we would get 6 spiniform in and transform it into 2 carbon nanotubes on site. Only I'm not doing 3 trips to get 1 vessel full of stuff. So we process it out in La La Land and we just bring this in as a raw resource. So that will be a raw resource. That will be bring in silicon, process on site. This one, we have to make the component parts. Titanium ore, right, just bring that in, process. Sulfuric acid, we've got that on tap out in La La Land. Steel, we need to go iron, and iron of course is iron. So, let's get some of our stuff here. Now the interesting thing about iron, 3 iron for 1 steel takes 3 seconds, which means that we can do, essentially, if this was an iron, 3 seconds produces 3, 3 seconds takes 3 and produces 1. So we can just go, thank you very much, straight from there into there, and it will spit out. So that makes things very easy for steel. Big, but generally easy. So what we will do, I guess, is let's start putting something down. We're going to size constrain ourselves. 2, 3, 4, 5. We are not going over this line. We're not going over the equator. 1, 2, 3, 4, 5. We won't go over this line. And that's simply because we can find a big patch like that on a planet, but there's not many. We could go bigger, but if we go bigger, then it gets harder to find a patch. There's usually stuff in the way, unless it's something we don't care about. No troubles. We've done this last bit. There we go. And we'll see if we can get it into 3. We should be able to get the imports into 3 and exports. Maybe even 2, we'll see. So let's start. We want the iron ore to steel. Let's grab iron. And maybe there'll be some left over. We'll see. We'll do that, and we want warpers as well, so we can get them from off amongst the stars. Local demand, we're not going to supply that anywhere. We'll go local demand and remote demand. The same here. That's just so once the local area gets stripped clean, we're still getting it from off-world. The warper says we're still getting it from other stars. So let's spin. Can't go over there. So I want a little bit of space at the end. 10. Would be okay. We'll put that in there for now. I reserve the idea of going out to 12 because that would give us quite a bit of steel once we get to that point. So, iron. We'll have this as our output line. So, pull in, push over, and output. But you know what? I am going to go out to 12. If I have to, we'll come back a couple. Alright. Let's put in these. We'll do it. Alright, now what we're going to do is we're going to come down and curl around. I hope I'm leaving enough room. We curve around, then and across it. Because this is our steel, there's our iron. And when you think about it, this is just, again, it's just a game. We're not going too much worries about ratios. Technically that is a ratio 1. But that's an admissible one. Most of these things, it's just the game holds our hand, tells us how much it's going to put out, and how many buildings we need. Might go back down to 10, we will see. Alright, let's put down that. I'm doing it this way because I've got a little bit of vertical space. I don't have to worry too much about it. Yeah, stop that. So those are going down there. Iron ore is going to come through probably till about there. So if this was 10, that would be 10, 20, 30 iron a second. Divide it by 3 because 3 iron per steel is 10 steel a second. Or in this case, because we've got 12, it'll be 12 steel a second. Which is actually a pretty good thing. Leftovers are always good. definitely doesn't hurt us. I hope anyway. Take that out to there. Oh, why did I do that? Goodness me. In fact, what I will do, what do I do? This one here. And then we'll go this one here. What? Excuse me just a second, I'm going to close the door. But too much wind gotten up out there. Better. Alright. So, that will be our steel. What am I doing here? We will go and put, probably not there, put the iron ore out there. Now, let's do titanium next. Yes, titanium next. Oh, before I do titanium, I better put down these just to make sure everything gets powered properly. Now, let's do that again. Titanium's easy, it's just titanium. 2 seconds per building. So for every building, if we put down 24 buildings, that will give us 12 titanium a second. And that matches quite well actually, perfectly with the steel per second. So yes, I think we will do that. But it's only a simple one line, thankfully. Don't have to go and curl it all over creation. So we'll bring in titanium, ore out, and the ore and out. This is a fairly simple bog standard build. Now this is to make three materials. This is to make the titanium alloy. So titanium alloy. Start by putting down another set of power poles. Titanium alloy, there we are. 12 seconds to make 4. Or 12 is working well. 12 smelters to make 4 a second. If we put down, there's a lot of inputs on that. So I've got those up here and bring them through. We want this and we will want an output build. What we'll do, we have this as the output build. Just see how that goes for a moment. We'll bring in acid here. Probably loop it around. Yeah. Let's mark this. This is just so I can hover everywhere and it says, oh yeah, that one's got acid. This one, put a marker on here as well. This one will have our titanium. This will have titanium. This is just an easy way of making sure I don't get mixed up. What is it? I can see anywhere. Oh yeah, if that belt's been wiggled around this way, not a problem. Okay, let's get back to the smelters. bring down a couple of belts and say that one of those is going to be steel and one is going to be titanium. Actually, we'll go a little bit further because there'll be some leftovers. These 12 take only 4 per, and we're getting 12 per. Then another 12, we'll take another 4, and we'll have some leftovers. Yes, makes sense to me. Acid down to here. We will chop that up there. Bring the titanium alloy there. I guess we'll just pop that onto that. This becomes titanium, yep. I guess this becomes steel. That works. Put in this to make sure that we do power it. Yeah, that covers it all, does it? Yes. Alright, let's do sorters. We want acid out to titanium alloy, in, acid and out to titanium alloy. Since we're going to have leftovers, first, let's say we bring in the titanium ore. How much good if we don't need it? Bring in acid there. Let me just have a quick look. In this one, we have acid. Right, we've got room for 2 leftovers. I think we might put them there. We can have acid, titanium there. Sorry, the grain material there. So we have those 2. We have raw material there. We may have to go through. Let's see. Because we probably should have. We're going to need a lot of titanium alloy, but we're going to have a lot left over. So yes. Alright. Decision made. Oh. Gee. Why don't I do that? Choose what we're putting. What's going to be first. Not sure if we need them in that one. We'll see. We say that this is going to be acid amount. I guess put acid in here. Feed this back into here. Oh, we are not going to have room, are we? If I feed it through like that. Let me see. That looks kind of smooth. Let's do the same for this one. This is the steel leftover, if I remember. Oh, if I remember correctly. That works. Oh, it's a little bit abnormal. I bet you it is because. Is that smoother? Yeah. Silly, isn't it? To worry about how nice it looks, type of thing. Alright. We need silicon ore, silicon. Silicon is left over. There'll be some. There will be titanium. This is unfortunately going to be, yeah, 3 of these, because we do want the titanium there. We could always just turn around and say to heck with it, we won't bother putting silicon ore there on the local network. It does seem kind of a waste not to. The interim will do it. Okay. We will have. Where's titanium left over? And since that will pretty much. We've got the silicon ore in here. Would make a lot more sense, wouldn't it? We'll think about that later. Let us do frame materials now. No, actually, let us do our silicon now. This one's the same as titanium. 2 smelters makes 1 silicon every second, so that will give us 12 silicon a second, no troubles. It would help if I gave the steel and titanium left over somewhere to go. Won't bother sending that remotely, or that remotely. We might do that remotely. This one I think we'll reserve for a more planet. Out. Out. Along about. don't think we will. Alright, so the next things we need, that gives us our 3 parts. Sorry, 2 of our 3 parts, the frame materials. And now we need our stubborn energy. Bring that in here. Would make sense. Materials. Assembler, 6 seconds to make 1. That means that 6 will make 1 per second. Well, we're not going to manage 12 there. Awkward. We'll make a gap there. Maybe we'll just put a 9. That's the whole length. So if we bring... What's the best way of doing this? We bring these 2 down the centre. We can bring... carbon nanotubes out, a bit like what we did here actually. Just use assemblers instead. Yes, carbon nanotubes out and frame material out. So yep, looks like a thing. And yes, actually, just double check that. Got 9, don't we? 18. Divide that by 6 is 3 a second, so yes, actually, that's still a good amount of frame material. Especially when I talk later about breeding and such like. Let's put in... and I think we better... oh no, that covers that. Silicon, whoops, like silicon through and into here, that will fit perfectly. Magic. Just mark that as silicon. There was a madness in my methods. This one will be where we bring in the titanium alloy. Here. Mark you as titanium alloy. Yep. I'm a little bit surprised that went in pretty much perfectly. Not designed that way. Very happy to have happened, yeah. Well, carbon nanotubes, here we come. These horrible beasties of things when you make them from spinner form. Oh, too far. Just bring that down there. Take it to there. And then output we will have here frame materials, and we may as well put it straight to there. It was one, doesn't it? I was hoping to get into 2, but there simply isn't room. We've got too many materials. If I didn't give a stuff about the leftovers, yeah, we'd easily get into 2. Although we might sort of run out of exit input, as it were. However, I do want the interims available, so leftovers available, so we let us sterilize these, that goes out. We have a little space without doing too much belt shenanigans. Effectively, we could just shift things over and what have you. But I'm not going to worry. That's good enough. I mean, do I want them all flat? Can't make them all flat, so never mind. Alright, that should be good. So what I'll do, that will produce 3 a second. Frame materials. Double check. 12 assemblers divided by 10 assemblers divided by 6 is 3. Yes. Alright, now I just need to mirror this on this other side. This is why taking a big block. In the end, that will give us 6 frame material a second, and if we upgrade everything with dark bulk stuff, 3 times the throughput there, 3 times the throughput there, we'll have boat loads. Probably put it into a Dyson sphere creator. Plug some of the outputs into that. Although, to be honest, it might be a bit difficult at our current stage to keep this fed, so we won't worry too much. Alright, I'm going to turn off the audio here, and I will speed this up so you don't have to watch me do something blindly. Okay, back again. Hopefully we can manage to get that back into the normal thing. But next step is fire it up. So, I'll have to found out Sandbox mode. So, materials. Very quickly. I have stuffed up anything, which I have. This is why we do things. Test them. There you go. Titanium. Come on. Yeah, this is still working. Should be a little bit of steel left over. We will see once it catches up. Let's see on this side. Yep, a little tiny bit of steel. So once this catches up, we'll do the same. Yep, there we are. Excellent. Have a look in. Alloy, nanotubes. It is all looking pretty decent. On the whole, yes. Satisfied with that. These will... not sure. Will remote command. This one will be local remote command. We may want supply, and that will be remote command. Don't want that going off planet. Don't care if that goes off planet. We'll leave it there. This one will only have local supply and local supply. I would consider this a successful test. I mean, if I wanted to do warpers via logistics bots and a small box on a splitter, push it into there, free up one slot there. And then we would have 1, 2, 3 slots available. You know what? I'm not going to worry about it. There is an advantage to having things a little bit spread out. Carbon nanotubes in this one. That's not a silly idea, no? I don't think those carbon nanotubes. Maybe my subconscious is saying bring the nanotubes in this one. The advantage is if we've got 2 remote pickups. You can have 3 remote pickups, but then that's a little bit less efficient. 2 pickups, 2 pickups, no pickups. We may as well wouldn't make things neater too. And when we look at that, silicon, titanium, carbon tubes. Yes, alright. Let's do that. Makes things a little bit, just a hair more efficient logistics wise. That's a good reason for not putting too much on the demand supply in one of these, because there's only 10. And the remote one's only got 10, so not a huge amount. If you're getting too much, say 4 or 5 inputs there, it's a little bit less efficient. So what we'll do is we will turn you off, drop you there, and remove you. The rest of those can be supply. We don't want supply. Just local supply, thank you very much. You can always change that at any time. Good thing about this one now is if I'm on another planet, I can come to this planet and go, yeah, I want you to be remote supply. Could be very handy. Even from another star system, you can do that. Just have to find where it is. Okay, I think we can consider that a successful build. So we'll leave it there. thank you very much. Cheers, have fun, and goodbye. Hello, Future Whisper here. As you can see, I have rearranged the belts somewhat to make things a bit neater, and in the process I have put leftovers into different towers, and yeah, I put the carbon nanotubes in here, the import, and then it's two imports, one import. You should be sweet, and one export. Off planet one and these ones. Technically there is one remote supply of titanium, which I really shouldn't worry too much about. It's going to be such a small thing. May as well just do it there. No, we'll leave it as is. But anyway, it neatens things up a bit. Not so much it's going over top of the belts and everything. Just makes it look a little nicer. If I wanted to, I could put a splitter type thing into there, join things up. There's no need. We're only making about 4 a second in here. Each side, so that's 8 a second. Relatively small amount. And as you can see, everything is running. So, yeah, again, we'll leave it at that. Cheers.